Okay, who can tell me what you got for the answer to the bell ringer?
Oh.
Sure, fine.
I got 891 centimeters squared.
Very good. So we should have used our 1/2 apothem times the number of sides times the side length, and then just substitute in. Remembering that a nonagon has 9 sides. Problem can't get much easier. Now what we're going to do today is make them harder. You will not know the apothem or you will not know the side length, and you'll have to figure them out using SOHCAHTOA or special right triangles. So it'll be a little bit harder today. Alright, so if you remember from Friday, we actually looked at some examples where we drew in segments to create triangles inside of the polygons. So regular polygons can be divided into isosceles triangles. So in this instance, you can take the center throw those in. What shape is this? Hexagon. Which means we have 6 sides. You'll also notice we have 1, 2, 3, 4, 5, 6 triangles. How many degrees are in a complete circle? 1 full revolution. Marquise? 360. So right here, all of these angles together have to add up to be 360. And we know that all of them have to be the same. So to find the measure of the vertex angle, you are going to take 360 and divide by n, the number of sides, which is also the number of triangles. So we have 6 triangles, 1, 2, 3, 4, 5, 6. 360 divided by 6 will tell me that each of these 60 degrees. Now, in order for us to find the area, we have to know not only a side length, but we have to know the apothem. So the apothem will cut that vertex angle in half. So if you take 60 and divide it by 2, you'll get 30 degrees. So the top of these will be 30 and 30. And then you can do triangle sum to find out the base angle. So this would have to be 60 and 60 just by triangle sum. That's what we're going to do on the first few examples. We're just going to find the angle measurements that we need. And then below, we'll actually take some problems where we're not given the apothem and we'll find the apothem using those angles. Alright, so for number 1, we have a pentagon. So this one we have 5 sides. So again, to find out what one of these vertex angles is, we will take 360 and divide by n. Which is 5. And that will get us 72 degrees. Which means that each of these big angles is 72. And it looks like one would be then 72. How would I find out what the measure of angle 2 is? Maddie? You got it. Cut it in half. We get 36. And that's because 72 has been cut into 2 congruent parts. To find the measure of angle 3, we now have, let me redraw this. The measure of angle 3 is this angle. So we can use triangle sum. 180 minus 90 minus 36. And that'll give me that the measure of angle 3 is 54. So this is important because if you don't know what the apothem is, you can use SOHCAHTOA to find out what the apothem is using sine, cosine, and tangent. Okay, the next one we have an octagon. They only drew a portion of it. They didn't draw the whole thing. So an octagon has 8 sides. And we see that the radius are drawn and an apothem is drawn. So we'll take, again, our full revolution of the interior angles would be 360, and we'll divide this by 8, which will get me 45. So 45 is the whole angle, which would be the measure of angle 1. To find out what the measure of angle 2 is, we just have to divide that in half. We should get 22.5. What would the measure of angle 3 have to be? Using triangle sum. Right?
I have a question.
Yes.
Since you know that it's only half, could you do 180 divided by 4?
No, because
You'd still get 45.
what do we get for measure of angle 3 then? And that was just using triangles. See if you guys can try number 3 on your own. Lexi, what'd you get for the measure of angle 1? Perfect. Measure of angle 2, Abby. And then the measure of angle 3, Jess. No. Marquise?
60.
Should be 60. So this one was a hexagon, which means we have 6 sides. And this one was kind of like this one we did. We didn't really do it, but we kind of talked about it. And then whenever we cut that in half, we do get our 30. And then doing our triangle sum, this would be 60. Who remembers the formulas for a 30, 60, 90 right triangle? Because we're going to need them today. Maddie? Alright, we're going to need that today because you'll see some of them ask us to leave it in simplest radical form, which means you can't use sine, cosine, or tangent because you'll need that square root. Alright, so finally into an area example. Find the area of each regular polygon. So remember our formula from Friday. Which of these variables do I know a value for? What do I know? Maddie? Yes, we know n is 6. We have 1, 2, 3, 4, 5, 6 sides. You can count. And we also know, Kaylin? Good, a side length is 20. The problem is, we don't know the apothem. So that's where we're going to have to use the angles we just talked about to figure out what the apothem is. So again, you might want to draw these in to find out what the angles are. We'll take 360 divided by 6, the number of sides. We get 60. We then divide that in half to get 30, which is telling me the top angles, you have to draw in your apothem to make 2 right triangles. And then now we have a 30, 60, 90 right triangle. Now, remember this is a regular polygon, so if one side's 20, they're all 20, which means this would be 10 and 10. So what would the apothem have to be in radical form? 10 root 3. Remember, this is your S root 3, This is your 2s. You don't need to know what the radius is. You just need to know the apothem. So the apothem will be 10 root 3. And then you can plug into your formula. Now, they want you to leave it in simplest radical form, which means you're going to have a square root of 3 in your answer. So half of 10 is 5. And then I'll just do 6 times 20 is 120. And then multiply those together, we'll get 600 square root of 3 centimeters squared. Now, sometimes they won't give you a picture, so you probably want to draw one. If you want to draw an octagon, you can. You also could just draw like the triangle that's going to be inside the octagon if you don't want to have to draw the whole thing. Some people aren't great at drawing an octagon, but eight sides. Sides are 18 inches long. The radius, now the radius, remember, touches the center and it touches a vertex, is 23.5. Now remember, you can draw a radius anywhere and it will be the same length. So again, we're finding the area. We know that n is 8. We know that the side length is 18. So the only thing we don't know is the apothem. There's two ways you can find the apothem. Let's draw it in. That will break the 18 into 9 and 9. What's one way I could find the apothem? Looking at my picture. Right. Pythagorean theorem. 9 squared plus b squared equals 23.5 squared. You also could, if you would like, you can do 360 divided by 8 divided by 2, and then you could use SOHCAHTOA if you like, but I would use Pythagorean theorem because then it gets a little bit shorter. So go ahead, square each of the numbers. Subtract 81. And square root. Now, a lot of you on your last quiz lost half points because your answers were rounded wrong. Do not round this answer, because you're going to round the final answer. So we should get 21.7082935. Let's see if I have my calculator out. Oh, shit. Now I wanted to show something on the graphing calculator that I don't know if I've shown in this class. So if you want, obviously you could just hit like times and it'll use the answer, but do you see this little answer button? I think the basic calculators might also have it. Yeah. So if you want to actually type that answer, use that answer in your next calculation, you can use this button. So this would be 1/2 times the apothem times number of sides is 8 and side length is 18. So if you wanted to type this in your calculator, you can do 0.5 times, and you would press second negative and it'll say answer. So it's going to use your answer from the last question. And then times 8 times 18. I also showed you guys how to store that in x, which is another way to do it. And you should get this. Now we can round this to the nearest tenth, which 9 would round the 9 to a 10, which would be 1,563.0 square inches. If you round this to 21.7, it might not get you the same final answer, so just be careful. All right, we have a hexagon with 10-foot sides. So let's go ahead and draw a hexagon. You're going to see the hexagon a lot. The hexagon always makes 30, 60, 90 right triangles, so you'll see it quite a bit. So right now we don't know the apothem. We do know that the number of sides is 6, and we know that a side length is 10. So again, we have to kind of create these little triangles inside, breaking this into 5 and 5. Now, we can't use Pythagorean theorem because we don't know two sides. So we have to find out our angles again. So use the 360 divided by n. So this whole thing is 60. We'll cut that in half to get our 30 and our 30. And then triangle sum will tell me that this is also 60 and 60. So now we use our special right triangles. Across from the 30 is s, so s is 5. Across from the 60 is s root 3. So this would be 5 root 3, which that's my apothem. This would technically be 10, but you don't need to find that for the problem. Now we can use our area formula. And again, you can multiply 1/2 times 5 times 6 and times 10. All the outside numbers will get multiplied together. And we will get 150 root 3. They want it in radical form, so we're not typing that into our calculator to get a decimal. And this will be square feet. All right, last one is the hardest one because it's going to have radicals. So we will be just adding a little bit of algebra to this. So first of all, we have a hexagon, 1, 2, 3, 4, 5, 6. What does 4 square roots of 3 represent? Does that represent a side length, the apothem, or the radius? Amira? No, it does not.
I mean the radius.
The radius, yes. Side length would be here. So this is our radius. The radius is not in the formula, right? So we're not plugging 4 root 3 in for anything. We need to find out what A and S are this time. We don't know either of those. All right, so remember, a radius can be drawn in anywhere. So you could draw in another one like there, or here, 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 here. And I'm just going to redraw the triangle. The radius always stays the same. So both of the sides of the triangle, the isosceles triangle, will be 4 root 3. So I'm just kind of redrawing like this. All right, draw in your apothem. Again, this is a hexagon. So just like we did in the last problem, we're going to end up getting 30 and 60 and 90. The only thing that makes this a little bit harder is we don't know what S is. We have to find out what S is. So label your formula triangle. Across from our 30 is S. Across from the 60 is S root 3. And across from the 90 is our 2S. So we have 2S has to equal 4 root 3. Solve for S. Now be careful. This is not this S. So we have two different S's that we're talking about, so be really careful. Plug this back into your picture. That would make this be 2 root 3. Now, the apothem is s root 3. So that's going to be 2 root 3 times another root 3, s root 3. This will get me to root 9. Root 9 is 3, so 2 times 3 will get me that the apothem is 6. So the apothem is 6. Make sure you don't make the mistake of plugging s as 2 root 3. This is the side length of one of the triangles. S really represents the side of the whole hexagon. So if this is 2 root 3, this is also 2 root 3, which when you add those you will get 4 root 3. So one of the whole things is 4 root 3. Now some students will say, Mrs. Bennett, that it happens to be the same as the radius. Yes, that does happen in a hexagon, only a hexagon. So for a pentagon that wouldn't happen, or an octagon that wouldn't happen, but in our hexagon we do end up getting, these are actually, if you look at this big triangle, 60, 60, 60, these will be equilateral. So in hexagon they will always be the same. But you still needed to do all that work because you didn't know what the apothem was. And now we can substitute into our area formula. And then just multiply all of your outside numbers together. All right, go ahead and try the closure problem.
Already. 5, 10, 20.